Okay, so look over here. As we completed all these points like conductance, reactance, and resistance, and like any I is equal to any VD for our current and all, isn't it? We are going to utilize some of the concepts of this. Let us write one question. बोल रहा है कि a current carrying wire, ठीक है, या फिर लिख लो a current a 2 ampere current लिखा हुआ है. Sorry, what is that? A 2 ampere current moves uh, or flows in a uniform conductor which has in a uniform conductor which has 1 into 10 to the power of 24 free electrons per meter. Okay, free electrons, listen perfectly. Okay, free electrons per meter. The question is very simple. Okay, what the question is simple. What is their drift velocity? Further, what is the drift velocity? Simply they are asking you. Try to do it fast. What is the drift velocity? They are asking. Okay. Here volume is not given, isn't it? But in reality, if you look into the question, volume is actually given over here. Look over here, see this. Here N will be what? Basically to define current, uh, uh, basically current is given, I have to find drift velocity. So I can use I is equal to any ABD. But N is what? Number of electrons per unit? Yeah. No, volume is not given. Here it is saying that I am having 1 into 10 to the power of 24 electrons per unit meter. So volume can be written as area into length L or not. Sorry, here let's suppose I write capital N. So here capital N by L is given, which is 1 into 10 to the power of 24 by area. Got it or not? So now I can use the formula. I is equal to NEA VD. N is what? 1 into 10 to the power of 24 by area A into 1.6 into 10 to the power of minus 19 coulombs into drift velocity is my 2 amperes of current. So basically, sorry, into I have to multiply area A. Sorry, NEA, uh, yeah, so A got cancelled and you can solve it. Got it or not? So you can, if you solve it, it will come as 2 is equal to 1.6 into 9 524 into VD. So VD is equal to, therefore drift velocity is equal to 2 divided by 1.6 into 10 to the power of 5. Why not? Is that clear? ठीक है? Okay, can I move ahead? Should I ask one more question? It's a little bit dependent on number of moles and all those kind of things. Okay. बोल रहा है there is a copper wire of cross section. Okay, there is a copper wire of cross section 1.0 millimeter square. Wide or not? And the current of 1 ampere flows through it. Got it? बोल रहा है if one electron per atom is free, okay, only how many electrons per atom? One electrons per atom is free. Okay, then question is find the drift velocity of electrons if if density of the copper wire is given, it is equal to 9,000 kg per meter cube. Are you able to get me or not? Yeah. Mass is not given. Yes, you have to consider the molar mass. आगे बढ़े. I'll give you one hint. Basically, density is equal to what? Mass by volume. Yeah. you have to consider, definitely molar mass you will have to consider. Okay. So that is basically mass means what? Given mass, यही होता है ना formula. Given mass by molar mass, yeah, into 1 by volume. That's what I'll do now. Into, and wait, that is equal to density by, means I can divide on both sides my molar mass or not, or atomic mass. Is that clear or not? Should I write basically molar mass is only means atomic mass, no? Okay. So given mass by molar mass, I can divide on both sides or not. So basically, uh, number of moles is also not given now. Only dense. Okay, so 1 minute, 1 minute. So basically, I can say that density by molar mass, as density is known, so this can be equal to number of moles divided by volume, isn't it? Because density by molar mass will give me the number of moles of atomic number of atoms or not, isn't it? And from this I can calculate number of free electrons, isn't it? So basically this implies that our number of moles is equal to, density is how much? 9,000 divided by molar mass 63.5, but it is grams now. This is kg minus 3. So it will become 10 to the power of 3 on up, isn't it? This is my number of moles. So in this, my number of atoms will be how much? This will be 9,000 into 10 to the power of 3 divided by 63.5 into 10 to the power of 23 number of atoms, which is equal to number of free electrons, isn't it? Is that clear or not? So you got your number of free electrons. Acha, sorry, I forgot to please. Forgot. 6.022. This is my number of electrons. So therefore, I is equal to NEABD. हमें क्या निकालना था? Drift velocity ना. So drift velocity is equal to I by NEA. So you can do it, isn't it? Volume. अरे अच्छा, number of moles I'm defining this as, okay, let us define. Let me write number of moles by volume. Okay. So this will be number of atoms per unit volume or not. Or this will be number of electrons per unit volume, which can be written as a small n or not. Got it? So I by NE, NE is this big number. Wow, nice. 9,000 into 10 to the power of 23, Baba, into 6.022 divided by 63.5. Okay, area is also given 1 millimeter square. So 1 into 10 to the power of minus 6 meter square into, okay, I N E, N A हो गया, E is 1.6 into 10 to the power of minus 19, and I is equal to put value 1 ampere and you'll get the answer. Are you able to get me or not? This is the whole calculation you need to do. I'll not do that. So I'm telling you the answer in this. In this, the drift velocity comes as, it gives me 7.321 into 10 to the power of minus 5 meter per second. Is that clear? Are you able to get me? Okay. So this is how you will solve the drift velocity problems. Like these kind of two questions can be asked. They too much harder they will not ask you. If they ask you numericals, it will be looking like this. Okay. Yeah. Okay. Can I move ahead? Yes. This involves quasi chemistry. I don't know that much of chemistry, but I am a chemist also because if I am a physicist, I can be a chemist. Okay. So let us move to our Ohm's law. Some problems of Ohm's law we will do. Okay. Right or not? Uh, is it? Okay, 1 minute. Yes, they are looking parallel now. Yes. Got it. I think they are looking perfect. Isn't it? So look over here. It is saying that let's suppose this is a cubical box which is given to you. Which kind of a box? Cubical box. Okay. And it is placed in XY plane like this way. Got it? This is X, this is Y, right or not? And this length is given to you from here to here, that this length is thrice of it. Got it? And this length from here to here is given also. It is equal to A, while Y length is twice of it. Got it or not? So question is find the ratio, find the ratio of resistance along X, Y, Z. Means you have to find Rx is to Ry is to Rz. Got it? Tell me fast. Mhm. Tell me. What is the formula of resistance? R is equal to rho L by A, isn't it? So let's suppose if I'm finding towards x-axis, that means you need to understand that it means one thing only, that the current is passing along x-axis. When you try to find Rx, you imagine that the current is flowing through which axis? X-axis. Are you able to get me or not? So when it will pass through x-axis, the particular length which it will cover, it will be area A or not? Yes, it will be area which? A. So rho into length is, it will cover from 0 to A. So length it will cover is 0 to A over there. Are you able to get me or not? So rho into area A divided by length is A divided by, I have to find area. So look over here, this current will be perpendicular to this particular plane, which is basically created by y axis and z axis or not? What it? So y axis length is how much? 2a, and z axis length is how much? 3a. So that area is how much? 2a into 3a. So you have to always consider length along the direction of current. Got it? And area perpendicular to the direction of current. So this is why this A got cancelled and Rx is rho by 6. Is that clear or not? Similarly, I can calculate Ry. For Ry, what will be the case? The current is moving along y axis. So length is 2a and area will be how much? For this current, the perpendicular axis will be this y and x plane, z and x plane or not? So zx, it is a into 3. So that is twice rho by 3. Are you able to get me or not? Similarly, I can calculate Rz. Rho current will move along 3a and area is this xy plane. So that is twice a into a. So that is 3 rho by 2. Are you able to get me or not? So basically the ratio is how much? Rx is to Ry is to Rz is how much? Simple. Rho by a it will be same. So I can write it directly. 1 by 6 is 2. 2 by 3 is 2. 3 by. Are you able to get me or not? So what is your net resistance then? What will be the net equation? What is the, then to understand this you try to find the LCM. What is the LCM? 6 or 9? LCM will be 6. LCM will be 6, isn't it? So it will be mm, basically how we used to do. We used to try to take a common value. What can be common value? Uh, 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 Sorry. It will be like almost 1 is to 4 is to 9. Yes. It will be 1 is to 4 is to 9. 3 to 6. 3 2 is 6. 3 3 is 9. Isn't it? And 2 2 is 4. So this becomes 1 is to 4 is to 9. Are you able to get me or not? ठीक है. Chalo. Can I move ahead? Okay, let us take some more questions of this resistance and all. and then we'll try to understand how the resistance depends on temperature and all. Okay, can I move ahead? So look over here, it is saying that let's suppose I have once again Baba, here it's too much warm and my room does not have AC set. It is happening. Okay. Control C, Control V. Okay. So I have, let's suppose, a cylindrical coaxial cable. किस तरह का केबल है? Cylindrical coaxial cable is there. Okay. Yeah. Control C, Control V. And it is placed like this. Are you able to get me or not? Now, the question is very, very simple. It's very easy. It's not that much tough. I don't ask tough questions, isn't it? The point is very, very simple that inside region, let's suppose the axis of the cylinder is drawn, given to you. Okay. It is like this way. Okay. So inside this cylindrical region, inner region, the resistivity of material is given and it is equal to rho 1. Are you able to get me or not? Outside region, I fill it up with different resistivity. Okay. So outside region, I have total different material and it is of resistivity how much? Rho 2. Are you able to get me or not? Inner radius is R1 and outer radius is R2. Is that clear, Balak? Yeah. This is R1 and this is R2. Question is find the equivalent resistance between 2 points A and B if the length of the cylinder is L. Tell me fast. Do it fast. Yeah. Hmm. Between A, point R of AB. Hmm. Mm-hmm. You can try to solve. It's easy basically. Basically, first of all, you need to understand that when I am transferring this current, okay, so this current is passing through both of these circular cross sections, isn't it? So basically, this inner region and outer region are at same potential or not. And when they are at same potential, consider that this is of resistance. Let's suppose I wrote it as capital R1 and this is of resistance capital R2. Right or not? So these resistances are in parallel basically, considering it to be a parallel resistance wire. Right or not? Is that clear? So equivalent resistance will be simply 1 by R equivalent will be 1 by R1 plus 1 by R2. So it will be what? Area 2 by rho 1 L1. L is same, isn't it? Length is still same. plus area 1, sorry, got it? So area A1 by rho L plus R2 will be, it will be area A2 by rho 1, yes, rho 1 rho. Got it. So now 1 by R equivalent is simply area A1 is how much? Pi R1 is square, area of cross section, isn't it? Rho 1 L plus A2 is pi. This rho 2 is present between R1 and R2. So I should write pi R2 square minus R1 square divided by rho 2. That's your equivalent resistance. You can solve it. You can take the common and all. Then we can get the answer. Is that clear? Are you able to get me? Okay. Should I give one more question? Okay. Question is very simple. If there is a conducting wire, okay, and it has length L, it has length how much? L. The point is very simple. That let's suppose if I connect this conducting wire with 2 points A and B, through which the current is passing, A, B, and here the resistivity at some resistivity is varying. Okay, let's suppose the resistivity at some point is given by equation rho is equal to rho naught x. What is the formula? Rho is equal to rho naught x. And if the area of cross section is A, got it? Can you hear me? Then find R of AB, resistance between AB. And this is perfectly solid. Easy peasy, it's not my god. Do it. Just solid, Baba. Such that the density will vary, resistivity is varying, that it needs to be solid now. Okay. Find the resistance. That's your question. बताओ क्या होगा आंसर? What? Rho naught L square by twice of A. Perfect, correct. So how did you calculate it? Basically, considering a uh, very good. Just consider a small element, yeah, which has width how much? Dx. So I can define a small radius for that. Rho dx by area is still the same. Area A, isn't it? So I can do the integration. So R is equal to integral rho, which is rho naught x dx divided by area A, and x varies from 0 to L. So rho naught L square by twice, isn't it? That's my resistance between AB. Are you able to get it? Okay. Can I ask you one more question? Okay, 1 minute. बोल रहा है कि there is a solid sphere and it is made annular. ठीक है? This basically outer region, basically out of solid sphere I cut it this small region. Got it or not? Okay. And it is saying that 1 minute. There are two radiuses basically. This is interior radius. Sorry, center will be where? Center will be here now. No, almost here, isn't it? So our radiuses are, let's suppose this inner radius is a small a and outer radius is b. Right or not? Then find the resistance between 2 points connected, one as outer layer of the solid sphere and one inner layer of the solid sphere. Find the resistance between point A and B. If this solid sphere is of resistivity rho, ठीक है? It's easy peasy once again. Tell me fast, what will be the answer? No. So if the current will move, this is the solid sphere. Okay. So current will go in which direction? It will go like this way, isn't it? From inner region to outer regions, isn't it? This will be my direction of currents, isn't it? Now, if it is my direction of current, and I know my inner radius and I know my outer radius, isn't it? Inner radius is A, outer radius is how much? B. So look over here. Basically, this current is intersecting a infinite number of hemispheres over here or not? Yes. Basically, a solid sphere can be imagined that a solid sphere is made up of infinite numbers of hollow. I said hemisphere. What I said? Hollow spherical cell of some thickness. Are you able to get me or not? And the current is always perpendicular to that hollow cell, isn't it? So area of the hollow cell is my going to be considered in terms of R or not? Yes. So let's suppose I consider a hollow cell at a distance x which has some thickness dx. Is that clear? So for this I can define my dr. Dr is rho, and see this current is crossing a length which is the thickness of the hollow sphere or not? Are you able to get me? So rho into what? Dx divided by, imagine, area. Area is that this whole current is going from all these sides. So the area it will subtend it will be the area of the hollow sphere, which is some nothing but I can write it as 4 pi r square, which is 4 pi x square, isn't it? Got it? And that integration I must do. So dr is equal to r, and that integration from a to b. So rho by 4 pi common, it is minus, the integration of 1 by x square dx is minus 1 by x from a to b. So r is rho by 4 pi 1 by a minus 1 by b. That's your answer. Got it or not? So if you want to understand how to break the particular things, cylinder, I'll break it in terms of area. Then all these kind of things you need to understand. Okay. Got it or not? Can I move ahead? One minute. So whenever you are solving resistance, draw the direction of currents. Okay. So let us do one more based on this. I have a solid cutted cylinder. Got it? like this way. Right or not? And here in this region, let's suppose I consider that this region is filled up. Right or not? Inside region is not filled up, and it has density how much? Rho. The density is given how much? Rho. Right or not? Now, if I connect them with wires A and B, it's easy question once again. Think like a sphere which we did earlier. Got it? No, I think 1 minute. It's not like that. Sorry. A and B is not like that over here. It's saying that A is this interior point and B is this exterior point. This is A and this is my point B. Got it? And inner radius is area A, radius A, and outer radius is radius B. Solve it. Yeah, you have to find R A B. Tell me first. Length is also given. No need to take tension. Okay. बताओ क्या होगा? Can I move ahead? Can I tell? Look over here. See, once again, basically, I told you not draw the current direction. If it is A and B like this way, the current will go like this way or not, isn't it? The movement of current will be what? Like this way? Are you able to get me? Isn't it? Similarly, like this way. So can I imagine that the smallest area, can I imagine that a solid cylinder is made up of infinite hollow cylinders? Yes, definitely. Definitely we can imagine. Not only, we can definitely imagine, isn't it? So let's suppose if I consider a solid cylinder to be made up of infinite hollow cylinder, yeah, you can place it like this way, but it's like, means you can something imagine like this way, got it or not? Yes. So basically, if it is made up of infinite such hollow cylinders, so let's suppose if I consider any hollow cylinder, got it or not? Let us make it a hollow cylinder. Let us make it. That's better. Got it. Got it or not? So in between it, I can consider one hollow cylinder over here or not? Yes. Now that hollow cylinder can be considered of some thickness and some radius, isn't it? You can align it. Control C, Control V, come over here. So let's suppose if I draw it, it will be like this way. It's looking like this way, isn't it? Almost mirror. It's little bit. I should make a thick diagram next time. Okay. So look over here. This one has some thickness, isn't it? You can see that it has some thickness. I'm considering it to be although hollow, but some thickness I'm considering. Are you able to get me or not? Is that clear or not? So let's suppose its thickness is, let's suppose it is located from the center at a distance x. Got it? And it has thickness how much? Dx. Are you able to get me or not? Is that clear? So then, once again I can define dr for hollow cylinder. It is rho into length. Length that is crossing this line, which is of thickness dx, isn't it? Are you able to get me or not? Divided by area. Area, it is basically here I have to consider the total curved surface area or not, which is 2 pi r l. Are you able to? R is what? X into length l. Are you able to get me or not? Yeah. Are you able to get me? So look over here. If I do the integration, so r is equal to, this integration must be taken from a to b, and rho by 2 pi l is constant, so it will come outside. 1 by x dx is ln x from a to b. Basically, this means that it is rho by 2 pi l ln b by a. Are you able to get me or not? Fine. Yes. Okay. Is this clear? So this was all about your resistance and all the variation of resistance. Okay. One more question I want to do. Wait. Last one, which has a very big importance. Okay. The last question. Oh my goodness, how much warm. Up to the problem with the rented house is this only. We can't buy our own AC. We can't get AC rooms, isn't it? In India, it's worst for summer season, specifically South India. I mean, Hyderabad currently, and it's hot like anything. So look over here. There is a box which is made up of two different materials of resistivity rho 1 and rho 2. Are you able to get me or not? And a current I is passed through this box, and this has area of cross section how much? A. Both. Yes. Is equal to how much? Area A. Got it. Question is very very simple. Find the charge on their common surface. Find the charge on their common surface. Yeah, basically their common surface is this now. The question is find the charge on that common surface. Hmm. What is the okay. A length is not given. Yeah. You can consider if you want to consider, you can consider L. हाँ मान सकते हो पूरा L. Yeah. Oh my goodness. Okay. 1 minute. So try this. Okay. I will.